I shall be going through this practice test set 2, paper 2H, which is paper 2 in the higher section of the exam, and I shall be going through walking and talking through each question, which will help you to answer these questions. Right then, so first question. Question 1 talks, questions a box is on a table, the area of the box is box in contact with the table is 1500 centimeters squared. The pressure on the table is 28 newtons per meter squared. Work out the force exerted, and they have also given you the formula for the pressure, force and area. Now the first thing for this question, okay, 1500 centimeters squared, but the units are not consistent. So the first step I need to do is convert my 1500 centimeters squared to meters. Now to convert from centimeters squared to meters squared, I have to times by 100 squared, because of this meter squared, okay, goes from centimeters to 100, centimeters to meters is multiplied by 100, but because it's meters squared, times it by 100. So when I convert my 1500 centimeters squared to meter squared, I have to divide it by 100 squared, and I'm going to use my calculator to work that out. 1500 divided by 100 times 100 equals 0.15 meters squared. So that's the area. Next I'm going to use the formula. The pressure is equal to force divided by the area, and I'm going to rearrange it because working out the force. So that the force is then equal to the pressure times the area. Pressure is 28, so I'll carry on working at 28 times the area, 0.15, and again with my calculator, 0.15 times 28 gives me 4.2. okay, and that's 4.2 newtons. Next question. Question 2. Bilal is making a set of 3 candles. He puts a white candle, a silver candle, and a gold candle into each set. The candles are sold in packs of different sizes. There are 25 white candles in the packet, 12 silver candles, and 8 gold candles in the packet. Bilal wants to use all the candles he buys. What is the smallest number of packs of white candles, silver candles, and gold candles he needs to buy? So essentially what this question is looking at is going to be the lowest common multiple. Lowest common multiple for those numbers. So you can either start off by writing out the multiples for each one. So 25, 50, 75, 100, and so on. 12, 24, 36, 48, 60, 8, 16, 24, 32, 40, 48, and so on. And you are looking for the lowest common multiple. The other way that you could do this question is by using your factors, prime factors. Okay, so 25 is 5 times 5. 12 is equal to 2 times 6, which would then become 2 times 2 times 3. And 8 is 2 cubed. 2 times 2 times 2. Using these 3 factor trees, I'm going to use a Venn diagram for this 3 numbers, 25, 12, and 8 there, so 25. So okay, 20, that's 5 and 5. 8 and 12 have got the common factors of 2 and 2, so that goes 2 and 2. 8, got another 2 there, and the 3 goes with the 12. So the lowest common multiple is when I multiply all of these out, all the numbers in the Venn diagram. So that's 2 times 2 times 2 times 3 times 5 times 5. So the lowest common multiple for these numbers is 600. The next step to work this out, to work out the number of packs, I need to divide how many packs I need to buy. That will make 600 for each type of candle. So that's 600 divided by 25, and 600 divided by 25 gives me 24. So that's 24 packs of the white candles. Again, 600 divided by 12 gives me 50, and there's 50 silver candles. And again, 600 divided by 8, which is equal to 75, and there'll be 75 packs of gold candles. The next part of the question is how many sets of candles can Bilal make from the packs of candles he buys? Well, we've already worked that out, which is 600. So again, all I need to do is I'm going to write the answer down: 600 candles. Question 3. Well, question 3, a square has a side length 8.4 centimeters. Work out the length of the diagonal of the square, give your answer correct to 3 significant figures. So with this question, what we're going to do, first part is, because it's a square, each length is 8.4, so this is also 8.4 centimeters. Work out the length of the diagonal. Diagonal would be from corner to corner, and what I need to work out is, if I draw out the triangle, it will be 8.4 and 8.4 with a right angle triangle. So this topic is actually looking at Pythagoras, and you're working out the hypotenuse, which is there. So using Pythagoras' formula, a squared plus b squared equals c squared, 8.4 squared plus 8.4 squared, and again I can use my calculator for that. 8.4 squared plus 8.4 squared equals 141.12. That's c squared. So from x squared is equal to 141.12. that gives me x at the square root of 141.12, and again use my calculator at square root of the answer, and I get x is equal to 11.87939392. I've written out the full answer, and now the last part is I'm going to round my answer up to 3 significant figures, which is up to there. So that becomes x is equal to 11.9 centimeters. Question 4. Okay, there's a total of 120 counters in a box. There are only red counters and blue counters in the box. There are 3 times as many red counters as blue counters in the box. Carl takes 1/3 of the red counters from the box. Kerry takes 80% of the blue counters from the box. Work out the ratio for the number of red counters to the number of blue counters now in the box. Give you a ratio in the simplest form. So this topic is on ratios. So the ratio, for the first part, red counters and blue counters in the box. So that's red to blue. There are 3 times as many red counters as blue counters. So for every one blue counter, there'll be 3 red. So that's my ratio, 3 to 1. And there are a total of 120 counters. So to work out how much red counters and blue counters there are, add the ratios up. So 1 plus 3 equals 4. Divide. So 120 divided by 4 is equal to 30. And then multiply. So 30 times 3 is equal to 90. So there's 90 red counters and 30 times 1, which is 30. Okay, so there's 30 blue counters. So now we know how many counters are in the box. Carl takes out 1/3 of the red counters. So for the red counters, and there's 90 counters in total. I want to work out 1/3 of 90, which is 1/3 times 90, which is equal to 30. So if Carl takes out 1/3, how many are left? Well, that will be 90 take away 30, which is equal to 60 red counters. So that's what remains. The next part for the blue counters. Kerry takes out 80%. So we start off with 30. So 80% of 30 is equal to 80 out of 100 times 30. And for this is 80. Use the fraction button. 80 divided by 100 times 30 is equal to 24. So 24. So Kerry takes out 24 counters. So that's 30 take away 24, which is equal to 6 blue. So now the ratio for the red counters to the blue counters, okay, so work out the ratio of the number of red counters to the number of blue counters. So red to blue, so there's 60 red and there's 6 blue, and that's my ratio. But now I need to simplify the ratio. To simplify the ratio, I'm going to divide it by the highest factor, and both of these numbers can be divided by 6. So divide both sides by 6, and I will end up with 10 to 1. So my final answer is 10 to 1. That was question 4. Question 5. Diagram shows a circular pond with a path around it. Pond has a radius of 5 meters. So the pond has a radius of 5 meters. The path has a width of 1 meter. Work out the area of the path. Right. So for this question, you've got a circle 5 meters and the path. So the other thing that we also need to know is the total length, the radius of the bigger circle, which will be 5 plus 1 equals 6. So I'm going to work out the two circles. And we're working out the area for the two circles. So for area equals pi r squared. And for the first circle, which I'm going to work out the smaller circle, the r is equal to 5. So area is equal to pi times 5 squared, which will give me 25 pi. I'm going to leave it in terms of pi until I work out the last section when I work out the final answer. And then for the second circle, r is equal to 6, which is the bigger circle. So again, area is equal to pi times r squared, pi times 6 squared. That gives me 36 pi. And now working out the area, well, it'll be the bigger circle minus the smaller circle, and that gives me 36 pi take away 25 pi, which is equal to 11 pi. So that's the area of the path. Now 11 pi, and I'm now going to use my calculator. 11 pi on my calculator equals, and use the SD button on my calculator to convert it. So the area is equal to 34.55751919, and now I'm going to round this up to 3 significant figures, so it's rounded up to there, and now my final answer will become 34.6 meters squared. So that's the area of the path. So I've got 11 pi, which is 34.5575. That's the full answer on my calculator. I've written that down first, and then the last step is I've rounded it up to 3 significant figures, 34.6. Question reads, the total cost of 3 apples and 4 pears is £1.84. Total cost of 5 apples and 2 pears is £1.76. Work out the cost of 1 apple and the cost of 1 pear. Now this topic, this is looking at simultaneous equations. So for this first part, I'm going to write out the equations using the abbreviations for each part. So this will become 3a, 3 apples, plus 4p, 4 pears, is equal to 184. So I'm converting that to pence, and you can leave it in pounds as well, but it'll be a lot easier when, and we need to remember that we've converted it to pence when we come towards the answers at the end. And for the second equation, 5a plus 2p is equal to 176. So first part, I'm going to look at, compare my coefficients. That's 3 and 5, they're not the same. 4 and 2, they're not the same. So for my simultaneous equations, these coefficients, one of them has to be the same for me to be able to add or subtract. But if I multiply the second equation by 2, I will get the 4p. So the second equation now becomes 10a plus 4p equals 300. So I can use my calculator just to make sure. 176 times 2, 352. And the first equation, I'm going to leave it as it is, because 3a plus 4p equals 184. So now I've got the 2 coefficients for the p the same. Using my stop, same, take away, opposite, plus. So the same, if the signs are both the same, I'm going to take away. So 10a take away 3a is 7a. 4p take away 7p, that cancels to 0. And then for the next part, 352 take 184, and again I'm going to just use my calculator to work this out. 352 take away 184 gives me 168. To work out the value of a, I'm going to divide both sides by 7. I'm divided by 7 and divided by 7, and now I get a is equal to 168 divided by 7, and that gives me 24. And because we've converted the pounds to pence, that gives me a is equal to cost 1 apple is equal to 24 pence. Next step, I'm going to use that answer and substitute it back into any one of these 2 formulas, and I'm going to substitute it back into the first formula. So now I've got 3, so using the first formula, 3a, so 3 times 24 plus 4p equals 184, and then 3 times 24 gives me 72, so that's 72 plus 4p equals 184, minus 72 from both sides. I'm left with 4p, and again the 72's cancel out there, 184, 184, take away 72 is equal to 112. And again, the last step, if I divide both sides by 4, because of the 4p, divide by 4, and then I've got 112 divided by 4 gives me 28, and that's 28 pence. And then for me to check my answer, I can use the second equation, the one that I didn't use, and use these values. And I don't need to show my working out. All I need to do is use the calculator. And that's 5 times 24, and again 5 times 24, that's 120, plus 2 times 28, 2 times 28, and I should get 176, which is the same answer. So that means I've checked my answer. So for question 7, here's a right angle triangle. Work out the size of angle marked X, and work out the angle marked X, give you answers to the nearest degree. This is a right angle triangle, as you can see there, and we work here at an angle. I've got two lengths, so we are using trigonometry. So from my right angle triangle, opposite the right angle triangle is the hypotenuse angle, okay, and again I can turn my triangle around to show that this is the angle. So this side is the adjacent, and that's the opposite. So this is the opposite, and that's the adjacent, is next to the angle and opposite the angle. So if I look at my formulas, sine, so cos, and tan, TOA. Well, I'm working out the angle, so, and I've got the opposite, and I've got the adjacent. So the opposite, I've got the opposite, I've got the adjacent. So this is the one that's, okay, so I've got both of those, opposite and adjacent. So this is the formula that I'll be using. So the formula is tan X is equal to the opposite divided by the adjacent, and if I substitute my numbers in, the opposite value is 14 divided by 7.5, that is tan X. So then to work out X on its own, the opposite of tan will be tan minus 1 of 14 divided by 7.5, and I'm going to use my calculator to work this out. Tan minus 1, 14 divided by 7.5 equals, and I'm going to write first part, full answer 61.82140989, and now, so that's the value of X, and give you answer to the nearest degree. So nearest degree will be the nearest whole number, so I'm going to round this up to the nearest whole number, which gives me 62 degrees. So this is now question 8, and the question reads: Jake is making badges of different shapes. Badge A is the shape of a trapezium, badge B is the shape of a rectangle, and he gives you the two shapes with their dimensions on the sides. In algebra, all measurements are in centimeters. The perimeter of badge A and the perimeter of badge B are equal. And Jake needs to work out the area of badge A. The area of badge A is in t centimeters squared. That tells us the units. Okay, work out the value of t. So the first part we're told is that the perimeter of the two badges is the same. It's equal. So we're going to work out the perimeter of badge A and badge B. So for badge A, it's got 4 sides for the trapezium. X, 3x plus 1, 3x plus 1, and 3x minus 2. So I've written it like, okay, as an addition. X, 3x plus 1, 3x plus 1, 3x minus 2. So 1 plus 1 minus 2 is 0. 3, 6, 9, 10x. So 10x for, and this is for A. That's for badge A. For badge B, rectangle, so therefore the opposite sides of the rectangle will be the same, so, and I need to add 2x, 4 sides, so that's 2x minus 3, 4x minus 5, 2x minus 3, and 4x minus 5, and total them up. So minus 3 minus 5 is minus 8, minus 16, and that's 8, 9, 10, 11, 12x. And that's for B. So the next, okay, so the next part we're going to make them equal. So, and I'll start off with, sorry, that's 12x. 10x equals 12x minus 16. I'm going to, okay, subtract 10x from both sides. And now I'm left with 0 is equal to 12x take away 10x, which is equal to 2x minus 16 plus 16 to both sides. And then I can write down 2x is equal to 16 and divide it by 2, therefore x is equal to 8. X is equal to 8. I made the two expressions the same, collected all the terms, all the x's to one side, and put the numbers on the other side. 2x equals 16 divided by 2, x equals 8. So the next part, what I'm going to do now, I'm going to substitute this value into my shape. And I'm working out the area by j, so I need the value of that. So x is equal to 8, so this value there is 8. And this is 3 times 8, take away 2. So 3 times 8, 24, take away 2 equals 22. And I already know the height, which is 24. So now the area of A, and I'm going to use the area for a trapezium, so the area equals half A plus B times H, where A and B are the parallel sides. So in our question, this is equal to half of 8 plus 22 times the height, which is 24. And I've now got, and again I'm going to use the calculator for this. So half times 8 plus 22, 8 plus 22 times 24, and I get the answer as 360. So that's the area of badge A. So on the answer line, I'm going to write 360 centimeters squared, because that's what the question said. The area of badge A is t centimeters squared, so t is 360 centimeters squared. Next question, question 9. On question 9, ABC is parallel to EFGH, GB equals GF, angle ABF, so angle ABF is equal to 65, and you have to work out the size of angle marked X, give reasons for your answer. So for this question, okay, as I work this out, I'm going to give reasons for each stage of the working out. So first question. What I'm going to start off with. We've been told in the question ABF is equal to 65, and what I also know is ABF. I can see a Z angle there, so therefore, okay, an alternate angle, so that's also 65. So that ABF is the same as BFG, which is equal to 65 degrees. And in the question it says give reasons for your answer. So for each stage of the working out, I'm going to give reasons. And what's the reason for this is that alternate angles are equal. Next, for this angle here, well, this is a, by this, we're told in the diagram, or you can see on those two small lines, that this is an isosceles triangle. So therefore, these two are the base angles. And for an isosceles triangle, the base angles are the same. So on the next line, description, I'm going to write BFG, which is the one that we just worked out, is equal to FBG. FBG, which is equal to 65 degrees. And again, I'm going to put it onto the diagram as well. And again, I'm going to write down my reason next to it. Base angles in an isosceles triangle are equal. So now we've got that. So the next third step, I'm going to look at now the triangle. So if I now look at this angle BGF, BGF is equal to 180. So angles in a triangle add up to 180 degrees. So take away the 65 and take away the other 65 as well, which is equal to 50 degrees. And the reason for that, angles in a triangle add up to 180 degrees. And then for the last part, x equals 180 degrees minus this angle, so I can put that on the diagram, 50 degrees. So x is 180, take away 50 degrees, which is equal to 130 degrees. And again, for the reason, angles on a straight line add up to 180 degrees. So that's my final answer. Question 9, and now question 10. Question 10 gives you a circular clock face, center 0, center O, has a mini hand OA, so there's a mini hand, and then an hour hand OB. The length of AB when calculate the length of AB when the hands show 5 o'clock, like it does on the clock, and he tells you OA is 10 centimeters, 7 centimeters. And what is asking for is the length from A to B. So we're working out this length here. And what we need to work out, we've got that length, the 10 centimeters, 7, and we need to work out the angle between those two lengths first. Well, the full clock face will be 360 degrees, and there's 12, and it's been divided up into 12 parts. So first step, 360 divided by 12. So 360 divided by 12 equals 30 degrees. So for each hour it's 30 degrees. So now we've got 1, 2, 3, 4, 5. So 30 times 5 equals 150 degrees. So that angle there, 150 degrees. Now I'm working out the length of a triangle, and it's a non-right angle triangle. I've got the angle and the two lengths, and what I need for this will be the cosine rule. Cosine rule. So the first step, I'm going to write out the formula. A squared is equal to b squared plus c squared minus 2bc cos a, where a is the length that we're working out. Cos a will be the cos of angle A. B and C will be 10 and 7. And now I'm just substitute the values in. So a squared is equal to 10 squared plus 7 squared minus 2 times 10 times 7 cos 150. And I'm going to put that all into the calculator, and what I get is this: 10 squared plus 7 squared minus, and I'm going to put this part in brackets, 2 times 7 times 10 times cos 150, and I get 270. So that a squared is equal to 270.2435565. And again, I've written out the full answer from the calculator. So the next part is to work out a is equal to the square root of all of 270.2435565 a, and so that's square root of the answer gives me 16.43908.624. And in the question it says, okay, give your answer correct to 3 significant figures. So now, once I've got the answer, I'm now going to round this up to 3 significant figures. So that's 1, 2, 3, third, 3 significant figures. So then that gives me a is equal to 16.4 centimeters. 16.4 centimeters as the answer for this question. Question 11 is on cumulative frequency, and the question reads: there are 200 workers at a factory. The cumulative frequency table gives information about the ages, and there's the information in the table. On the grid opposite, draw a cumulative frequency graph for this information. And part B, Graham says 10% of workers at the factory are older than 65. Is Graham correct? You must show you're working out. But for this first part, I'm going to use this information and draw the cumulative frequency graph. So I need a table of data, and I'm going to use that to plot my coordinates on my cumulative frequency. So, and when you remember, we need to plot the highest value on your inequality with your cumulative frequency. So age at 20 goes to 25. So on my graph, age is 20, and on my scale, each small box is worth 2, going up in 2s. So therefore 2 and 25, it's there at 30. And again, use my ruler to make it easier. 30 goes to 70, which is exactly on the line there. 40 goes to 138, and again 138 is there. Next one, 50 is 175, 50, 175, and 60, 186, 180, 246, 186, 70 is 194, 190, 24 there, and then for the last point, 80, 200, 80 to 200, which is there. So I've got my points, and now I need to draw my cumulative frequency curve, and I'm going to draw this freehand so that it's a smooth curve, okay, dot to dot. So from point to point, we'll start from there, first point, and go through each point, and it's a curve. This middle part straightens out, and I can use a ruler for this middle section. So the curve at the edges, but then I'm going to use a ruler, make sure it goes through the points. And again, for the last part, again I've turned my paper on its side so it's easier for me to draw. Starts from 0, goes through the point, and then I'm going to join that onto the next point there. So this is now my cumulative frequency curve for this data. So that's the first part of that question. Next, Graham says 10% of the workers at the factory are older than 65. Is Graham correct? You must show you how you get to your answer. So on my cumulative frequency curve, I'm going to go to the age of 65. So on my graph, 65, and I'm going to show my working out. So at 65, which is again going up into 2, 4, 5, halfway there. So at 65, I'm going to draw, use my ruler, and draw a vertical line going all the way up to my curve. Drawing the line from 65 going all the way up, and then the next step is I'm going to draw a horizontal line to see what number, what value I get to on, and on this, okay, I'll get to 190. So for 165, okay, draw the line vertically first to the curve, going across to 190. So first part, how many workers are there older than 65? Well, this section from 0 to 190 are going to be younger than 65. So, and this section here, which will be above 65, will be this part here. So my working out will be 200 take away 190, that gives me 10 workers at the factory that are older than 65. And now I need to work out the percentage. So the percentage will be 10 divided by the original, which is 200, times 100 to get my percentage. So using the calculator, fraction button, 10 divided by 200 times 100 gives me 5%. 10% of the workers are older than 65. Is Graham correct? So if I use that information, I can say no, 10% of the workers are not older than 65? It's only 5%. So in final, is Graham correct? No, only 5% are older than 65. And that's my answer. Question 12 reads, when a number is reduced by 30%, the answer is what? 17,920. What is the number? So this is looking at percentages, and it's all, and the value has already been reduced by 30%. So first part I'm working out, 100 take away 30 equals 70%. So that number represents 70%. So I'm going to write 70% equals 17,920. To work out 1% first, I'm going to need to divide by 70. So I'm going to divide that by 70 as well. So on my calculator, 17,920 divided by 70 is equal to 256, and from that I'm going to get to 100%, which is multiplied by 100, sorry, which is equal to, multiply that side by 100 as well, again times 100 equals 25,600. So my answer is 25,600. Question 13. Question 13 looks at probability, and the question reads, there are only 4 mint biscuits and 1 toffee biscuit in a tin. There are only 5 mint sweets and 3 strawberry sweets in a packet. So we've got a tin and a packet with different sweets and biscuits in there. Michael's mum lets him take 1 biscuit from the tin and 1 sweet from the packet. So he's going to select 1 from each. Michael takes a biscuit at random from the tin. He also takes a sweet at random from the packet. Work out the probability that either the biscuit or the mint is mint, but not both. You can't have both of them the same, but it has to be 1 of each. So for this, we're going to be we need to draw a tree diagram, probability tree. So what we're going to look at is, first part, looking at the tin. In the tin, so I'm going to write that's the tin of biscuits. What's the probability of getting a mint sweet, a mint biscuit rather? There's 5 altogether, 4 plus 1, so that is 4 out of 5. So therefore the toffee, there'll be 1 out of 5. For the second option, I've now got that's the packet. So the packet of sweets, and again I can have a mint or strawberry. So again, mint or strawberry. And the same thing for my second choice there, the mint and the strawberry. So, and then the next part, fill the numbers in. Again, there's a total of 8 sweets in the packet. So for the mint, there'll be 5 out of 8. For the strawberry, 3 out of 8. And again, 5 out of 8 and 3 out of 8. And that's my completed tree. So I'm going to look at all the options. Well, if I first part list all the options, then we'll be able to select the ones that we need. So First part, mint, so I'm going to write it there, mint, that's mint strawberry, that's toffee mint, and last one, toffee strawberry. And work out, so if we go back to the question, work out the probability that either the biscuit is mint, or the sweet is mint, but not both. So you can't have both of them. So we can't have both of them mint, so we're not going to use that. So the only two other options that are left are where we have the mint and the strawberry, and the toffee and the mint. And again, we don't need the one does not have the mint. So for probability trees, as you go across, we're going to multiply these fractions. So this is going to be for the mint strawberry, it's 4/5 times 3/8, and we work it out, which is equal to 12/40, and for the toffee mint gives us 1/5 times 5/8 times 5/8, which is equal to 5/40. And again, the question reads, okay, either a mint biscuit or a mint sweet. So for the last step, what we need to do is add these two fractions together. So my final stage of the working out will be 12/40 plus 5/40, which gives me 17/40. And that's the final answer, 17/40. What you need to know throughout this question, I've not tried to simplify these fractions, because if I simplify them, then I would need to work out the lowest common multiple for the denominator. But when you multiply them here, the denominators are the same, so I can leave them and make it a lot easier to work out. So that's question 13. Question 14. The diagram shows a trapezium, and here's a trapezium, and on the sides, the base and the two lengths and the height are given in algebra. All of the measurements are in centimeters. The area of the trapezium is 46 centimeters squared. Show that x squared plus 2x minus 5 equals 0. So in this question, they've actually given you the answer, and what they want you to do is show all the steps that you need to take to get from this diagram to the answer. So you have to show all the steps in between. So first part, the area of the trapezium, I'm going to write the formula down, which is half of a plus b times h, where a and b are the parallel sides. So that's a and b, h is the height. And I'm going to substitute these values into these algebra terms into the formula. So the area is equal to half of a plus b, so I'm going to add those two terms of 3x plus 1 plus 5x plus 3 times the height, which is 2x plus 3. And I'm going to now try and simplify this. So 3x plus 5x equals 8x, 3 plus 1 equals 4, 2x plus 3, and I've still got the half. So now I'm going to multiply this first term by a half. So all that means is I'm going to half each of the values inside. So half of 8x is 4x plus 2, and then this second bracket stays as 2x plus 3. And I'm going to expand that bracket out using 4 times 2x gives me 8x squared. 4x times 3 gives me plus 12x. then 2 times 3, sorry, 2 times 2x plus 4x, and the last part 2 times 3 plus 6. And at this stage I'm going to write down, look at what we were told at the start. The total area of the trapezium is equal to 46, so that is equal to 46. Simplify this expression, I get 8x squared plus 16x plus 6 equals 46. Now I'm going to bring the 46 to this side, so take away 46 from both sides, and 8x squared plus 16x plus 6 minus 46 gives you minus 40, and now that equals 0. Now with this quadratic, each term has a factor of 8, so I can now divide each term by 8 and the quadratic will still stay the same. So now divide each term by 8, so that becomes x squared plus 16 divided by 8 equals 2x, and 40 divided by 8 minus 5 equals 0, which is what we were asked for at the start. For the second part, now what they've said, what the question reads is, solve the equation x squared plus 2x minus 5 equals 0. Give your solutions correct to 3 decimal places, so you got more than one answer. So now we're going to use this. Now this should give us a good indication as to what we need to use, and because this is a calculated question and we are assuming that the answer is going to be in decimals, because that's what they want us to round it up, what we're going to use is the formula, the quadratic formula. So x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in this question, a is equal to 1, b is equal to 2, and c is equal to minus 5. So now I'm just going to substitute these into my equation. So that gives us x is equal to minus 2 minus b plus or minus b squared, square root of b squared, 2 squared, minus 4 times a, 4 times 1, times minus 5. Make sure that square root goes all the way to the edge, and then all divided by 2a, 2 times 1. And I'm now going to simplify that, and I can use the calculator to work this part out. The first thing I'm going to work out is what's this square root part. So that gives me 2 squared minus 4 times 1 times minus 5, and that gives me 24. So now my equation is x is equal to minus 2 plus or minus the square root of 24, all divided by 2. And to get the two answers, I'm going to now separate the plus and minus out. So x is equal to minus 2 plus the square root of 24 divided by 2, or x is equal to minus 2 minus the square root of 24, all divided by 2. And I'm going to use my calculator to work this out. So using the fraction button, minus 2 plus the square root of 24, use the blue arrow button, to the denominator divided by 2 equals, and it gives me an answer in third form, but I'm going to convert it using the ST button to a decimal. So now I've got x is equal to 1.4494897 or, and for the second part, this time I'm going to enter it using the minus. So again, fraction button -2 minus the square root of 24 all divided by 2, and this time it gives me x is equal to -3.449,743. And now I've got the two answers for x, and I need to round my answers up to 2 decimal places. So my answer for x is equal to 1.45, or x is also equal to -3.45. Question 15 is to do with transformation of graphs. And the question reads, the graph of y equals fx, function of x, is shown on the grid. So you've got fx, which is this graph here, and the graph g is a translation of the graph y equals fx. So that's your translation. Write down in terms of fx the equation of graph g. So if I look at 2 corresponding points on the 2 graphs, so for example, if I look at this point here, the corresponding point for that same graph is there. So what's happened from the original to the new graph? Well, that point has moved 1, 2, 3, 4, 5 squares to the right. So it's translated 5, 0. It's a translation 5 squares to the right. So for my equation and for transformation of graphs, if it's been translated left or right, it's the inverse value, the opposite value inside the bracket. So what that will mean is my answer will be fx minus 5, because it's moved 5 to the right, so inside the bracket is the inverse, is the opposite value. So y equals f of x, f bracket x minus 5, and that's my answer. X minus 5. It's been translated 5 squares to the right. Now, part B, the graph of y of fx has a maximum point of minus 4, 3. Write down the coordinates of the maximum point of the graph of y equals minus fx. So, well, minus 4, 3 is what we had at the start. And that function, minus fx, is a reflection. So the minus means that minus inside the bracket means it's a reflection in the y-axis. So it's been reflected there. So what's going to happen if that original graph y equals fx, if it's reflected there? Well, that point will 1, 2, 3, 4 points away from the y, so therefore it will end 1, 2, 3, 4. It will end up here. So that point will get reflected. So I'm going to write down it's a reflection in the y-axis. So therefore the coordinate for this new graph, this new point, will be 4, 3. So that's 4, 3. So inside the bracket, it's been reflected in the y-axis. Question 16. looks at recurring decimals. So again, they've given you that x equals 0.015 recurring, and the question reads, prove algebraic that the x can be written as 1/66. And again, they've given you the answer, so what you need to do is show how you get from the question to the answer. So first step, I'm going to write down what the value of x represents. So 0.0151515. So that's a recurring number, continuous forever. Next, I'm going to multiply this. So I want a whole number at the start, and I'm going to multiply this 1, 2, 3. So that gives me 1000x. So I want the recurring part to be at the start. So 1, that's 1000x, will be 1, 2, 3. So that's 15.151515, and the rest is still recurring. And then again, I want, if I will start with the original, I want to multiply this so that this recurring part is the same. So that I've got the 1 as the first value after the decimal point. So if I multiply this original by 10, I will then get 10x is equal to 0.151515. And if you note, look at I've made sure that my numbers are lined up, so it makes it a lot easier for me to look at the recurring part. So the next step, to get rid of the recurring part of my numbers, I'm going to subtract the two values. So 1000x take away 10x gives me 990x. When I subtract these two values, the recurring part for each value will cancel out. So that gives you 15 take away 0 is equal to 15. And to work out the value of x, I'm going to divide both sides by 15. Sorry, by 990 rather. Divided by 990. 990. So now I've got 990 there and 990 there. So x is equal to 15 divided by 990. And I can divide this, okay, both got a common factor of both 5 and 3. So I'm going to, if I divide it by 3, that will simplify to 5 over 330. And again, I can simplify it further to give me 1 over 66, which was what was required at the start. So x is equal to 1 over 66. So x, which was the recurring value, is equal to 1 over 66. Question 17. Question 17 reads, p is inversely proportional to the square of x. Given that x equals 5, p is equal to 6. Find the value of p when x equals 8. Give your answer correct to 2 decimal places. So first part of the question, we can use this information. P is inversely proportional to the square of x. So this is looking at proportional directly and indirectly, or inversely proportional. So what that means, P will be proportional to the inversely proportional, so that's 1 over the square of x, x squared. And I can then change that symbol, proportional symbol, to an equals by introducing my constant k. So p is equal to k over x squared. Now in the question we're told x equals 5 when p equals 6. So p equals 6 and x equals 5. So I'm going to substitute that into my equation to work out the value of k. So P6 is equal to k divided by 5 squared. And I'm going to multiply by 5 squared, 25. 5 squared, which is equal to 25. So now k is equal to 6 times 25, which is equal to 150. Now that I've worked out k, I'm going to substitute this back into my formula, my proportional formula that I've started off with. So now my formula becomes P equals 150, which was k, divided by x squared. So now I need to use this formula to work out the final part of the question. So now when x equals 8, my formula will now become P is equal to 150 divided by 8 squared, which is equal to 150 divided by 64. And again, put that into the calculator. 150 divided by 8 squared, which is 64, and that gives me 2.34375. And in the question it says, well, round the answer up to correct to 2 decimal places. So now I'm going to round this up to 2 decimal places. So then that gives me P is equal to 2.34. So let's round it up to 2 decimal places. Question 18. For question 18, question 18 gives you a graph, and it reads that the graph shows the velocity v meters per second of a rocket at time t seconds. So that scale is your velocity scale, which is in meters per second, and time t in seconds. And the questions asks to find an estimate for the rate of change of velocity of the rocket at t equals 2. So t equals 2. So what we need to do for this, first part we need to look at what does that mean. What is the rate of change? The rate of change means you are looking at the gradient. So at 2 we are going to work out the gradient on the graph. So what we are going to do is, using our ruler, I'm going to use my ruler to draw a tangent to the curve at t equals 2. Now you could have a slightly different gradient, and there is a range of values for the answers that you can have. So there is you might have a slightly different answer to mine, but your method is what they are looking for. So here's my tangent, and I can carry that on, and then from the tangent I'm now going to work out the gradient of that line. So again, I'm going to look at, let's go to 3. I can draw a triangle here. So, and to work out the gradient, the change is the difference in y divided by the difference in x. So now the difference in y, it starts from 0 and it goes all the way up to 20. So the difference is 20 minus 0, and for the x value it goes from 3. So 3 take away 1.3. and that gives me 20 divided by 1.7. And again, use my calculator. 20 divided by 1.7 gives me that value there, which is 200 over 17. And I'm going to write down the full number first, 11.76470588, and I'm going to round this up to 1 decimal place, even though in the question it doesn't say, but I'm going to round this up to but I've given them the full answer already, but I'm now going to just round it up to 1 decimal place. That gives me 11.8 meters per second. Meters per second squared, which is the acceleration. Question, that was question 18. Question 19. Question 19 looks at values that have already been rounded up. So our road is 4,530 meters long, correct to the nearest 10 meters. Kirsty drove along the road in 205 seconds, correct to the nearest 5 seconds. The average speed limit for the road is 80 kilometers per hour. Could Kirsty's average speed have been greater than 80 kilometers per hour? We must show you working out. So for this question, where you've already had numbers that are rounded up, this is topic on bounds. And we can, first part, work out the upper and lower limits, upper and lower bound for each of the two values that we're going to be using. So for 4,530, I want the lower bound and I want the upper bound of the speed of the distance. Lower bound. Now because it's been rounded up to the nearest 10 meters, if I divide that by 2, that's 5. So I'm going to add 5 and take away 5, and so that gives me the lower bound as 4,525, 4,535. And for the time of 205 seconds, again it's been rounded up to the nearest 5 seconds. So 205, and for 205 I'm now going to look at, because it was 5 seconds, if I divide that by 2 equals 2.5 seconds, so I need to add and subtract 2.5 from that value. So 205 take away 2.5 gives me 202.5 as the lower bound, and the upper bound as 207.5 seconds. So I've got the values that I need to use, and I'm going to have, for next part I'm going to look at how to work out average speed. Well, the speed formula is speed equals distance over time. I'm going to use the triangle, and to work out speed, so we're working out the speed, distance divided by time. So speed equals distance over time. Now, to work out the largest possible value, the greatest value, I need to use the upper bound. I need to use the upper bound of the distance divided by the lower bound of the time. I need the upper bound of the distance and the lower bound for the time to work out the greatest possible value that I could have with these values. So I'll substitute those in, and now I have the upper bound of the distance, which is 4,535 divided by the lower bound of the time, 202.5. So my speed is equal to 4,535 divided by 202.5, which gives me
22.39506,173.
But this speed is in meters per second, and I need the question is in kilometers per hour. So I need to compare that to kilometers per hour. So I need to convert the meters per second to kilometers per hour. So what we're going to do to convert it, we'll use that value 22.39506,173, and I'm going to times it by 60 times 60. So 60 seconds times 60 minutes, and then I'm going to divide that by your meters to get from kilometers, from meters to kilometers. You divide that by 1,000. So 60 times 60 converts minutes from seconds, minutes to hours, and divided by 1,000 to get to kilometers. So put this value in to my calculator, and I've still got the answer stored. So I'm now going to do times 60 times 60, all divided by 1,000, and that gives me an answer of 80. So the speed is equal to 80.62 reoccurring kilometers per hour. So if I go back to the start of the question, could Kirsty's average speed have been greater than 80 kilometers per hour? So my last part of the question, I'm going to answer yes. Kirsty's average speed could have been greater than 80 kilometers per hour. Question 20. Question 20 looks at quadratic sequences, and it reads, here are the first four terms of a quadratic sequence: 7, 18, 33, 52. Find an expression in terms of n for the nth term of the sequence. So I'm going to, first step, list out the sequence. I'm going to find the first difference. So 18 take away 7 equals 11. 33 take away 18, which is 15. 52 take away 33, which is 19. And then for the second difference, for my quadratic, 15 take away 11 equals 4. 19 take away 15, again it's 4. So now I've got the same difference on the second. After that, I've taken the second difference, I need to divide this value, divide it by 2. So 4 divided by 2 is equal to 2. So now the first part of my rule is going to be 2n squared. For my rule, this is my first term, and I'm going to label it now 2, second, that's the third, and that's the fourth. So this is the n number, the nth term. So if I substitute this value into the sequence, so when n equals 1, 2n squared is equal to 1 squared times 2 is equal to 2. 2 squared is 4 times 2 gives me 4. 3 squared is 9 times 2 is 18, and 4 squared is 16. 16 times 2 gives me 32. Look at the way that I've set this out. I've made sure that my term numbers are level, which will make it a lot easier for me when it comes to my working out. So the next step, I'm going to now subtract the 2n squared part from my original sequence. So 7 take away 2 gives me 5. 18 take away 4, sorry, that's 4 squared is 8 rather. Okay, 2n squared, 2 squared is 4 times 2 is 8. 18 take away 8 equals 10. 33 take away 18 is 15. And 52 take away 32 is 20. So now I'm left with a new sequence. So I've subtracted out the quadratic part from the sequence, and now I've got a linear sequence. So, and again, I'm going to work out the nth term rule for this sequence. That's the first, second, third, fourth term. So the first difference, the difference between them is going up in 5s. So 5 plus 5 plus 5 plus 5. So then the first, my rule starts off with 5n plus 5n. And to work out the previous term, if I go back one value there, so 20, 15, 10, 5 is 0, so the 0 term is 0 on this. So then my final answer then becomes those two terms put together. So the rule for this is 2n squared plus 5n. Question 21 looks at functions. And the question gives you two functions at the start, gx and fx. And the question reads, given that x is greater than 3, find the exact value of x such that the inverse of gx is equal to fx. So the first step I'm going to do for this question, I'm going to work out the inverse function for this. So gx is equal to 4x over 3 minus x. And I'm going to make that equal to y as well. So y is equal to 4x divided by 3 minus x. So I can write that underneath. Y is equal to 4x divided by 3 minus x. For your inverse functions, what we need to do is, first step is to swap the letters over. So x is equal to 4y 3 divided by 3 minus y. So I'll swap the letters over, and I'm going to again swap x and y. Put that there to help to remind people what I've done. Next step, I'm now need to rearrange this to make y the subject again. So first step, to multiply, bring the 3 minus y to this side, so that becomes x bracket 3 minus y equals 4y. Expand the bracket, 3x minus xy equals 4y. Collect all the y terms together, so that's plus xy on both sides. So now I'm left with 3x is equal to 4y plus xy. Factorize this, and I'm left with 3x is equal to y bracket 4 plus x. And now make y the subject on its own, so therefore that gives me 3x divided by 4 plus x equals y. And then I can rewrite this out using the inverse of gx. So that gives me g to the minus 1 of x, the inverse function of gx, is equal to 3x divided by 4 plus x. Next step, I'm told that the inverse function of g and fx are both equal. So now I'm going to rewrite this out and make this equal to 2x minus 5. So let me just divide the page up into two so we can see what we're doing. So now 3x divided by, and I can rewrite this out in an easy way, x plus 4. So that's x plus 4 is equal to 2x minus 5. And this next part is to do with algebraic fractions. And now I'm going to work out the value of x. So first step, bring the x minus 4 over to this side. So now that becomes x, and I'm going to introduce my brackets. So that becomes 2x minus 5 and x plus 4. I'm going to expand the brackets out. So 2 times x, 2x squared, 2x times 4 plus 8x minus 5 times x minus 5x minus 5 times 4 minus 20, and it all equals 3x. And I'm going to subtract 3x from both sides to bring 3x to this side, so minus 3x and minus 3x. And now I'm going to simplify the whole quadratic, so now that is equal to 0. So now I've got 2x squared, 8x minus 5x is 3x, minus 3x equals 0. So all of these x terms are equal to 0, and I'm only left with 2x squared minus 20 equals 0. Both got a factor of 2, so I can divide my quadratic by 2, and I'm left with x squared minus 10 equals 0. So now I need to work out the value of x. Well, if I look at this looks very similar. This is a difference of two squares. So what this is x plus the square root of 10 and x minus the square root of 10 equals 0. So therefore x plus the square root of 10 equals 0. So x equals minus the square root of 10, or x minus the square root of 10 equals 0. So therefore x equals the square root of 10. So I've got two answers. Now if we go back to the question, x is greater than 3. Well, this value is going to give me a negative value, so I'm not going to choose that. So therefore my final answer is x is equal to the square root of 10.